Oh. Hi, we are group A12 and we are going to talk about basic ideas of sorting. And we are going to give a brief introduction of insertion sort and bubble sort. First of all, we are going to look at the definition of sorting. Sorting is basically putting a list of elements into a list in which the elements are in increasing order. I'm going to give a very brief example. For example, we have a list of numbers 7, 2, 1, 4, 5, 9. If we sort this, we're gonna have the numbers in increasing order. That would be 1, 2, 4, 5, 7, 9. As you can see, the numbers from the front to the end are in increasing order. And also sorting can be used in a list of alphabets. So for example, if we have a list of alphabets A, C, T, P, F, E, and if we sort this out, we're gonna have a list of alphabets, something like A, B, C, D, E, F. And as you can see in this example as well, the alphabets are in alphabetical order from the front to the end. There are many kinds of sorts, but we're gonna just give brief introduction of two sorts, and Lyndon is gonna talk about bubble sort.
Right. Okay. So, bubble sort. The definition of bubble sort is putting a list into increasing order by successfully comparing adjacent elements, interchanging them if they're in the wrong order. What that means if we have a sequence 3, 2, 4, 1, 5. In the first pass, it's going to compare the first two numbers, 3 and 2. Since 3 is bigger than 2, they switch places, so it becomes 2, 3, 4, 1, 5. And now the sort looks at the second and the third number, 3 and 4. Since 3 is already bigger than 4, it stays like that. So then it looks at the third and the fourth number. Since 1 is smaller than 4, it will go in front of 4, like such. And the last comparison in this pass will look at the fourth and the fifth number, 4 and 5. Since 4 is bigger than 5, they stay like that. And that is the first pass. So now it goes down to the second pass with 2, 3, 1, and 5. In the second pass, it goes to the same comparisons, comparing the first two numbers, 2 and 3. Since it's already the same, it stays the same. And now looks at the second and the third number, 3 and 1. Since 1 is smaller than 3, it moves. I switch places with 3, becomes like this. And then it looks at the third and fourth number, because 4 is bigger than 3, they stay in the same places. Same goes with 4 and 5. So that was the second pass. Now the sort moves to the third pass with 2, 1, 3, 4, and 5. Again, it looks at the first two numbers, 2 and 1. Since 1 is smaller than 2, they switch places. It becomes 1, 2, 3, 4, and 5. And it checks the second and the third number, and then checks the third and the fourth and the fifth, because they're in the right order, in increasing order. Thus they stay the same, and that's the third pass. And it does one more pass to check the whole thing, 1, 2, 3, 4, and 5. It is in the increasing order, thus the sorting stops, and that is the bubble sort. Now Connor will talk about the insertion sort.
Okay, so the insertion sort. The insertion sort is another type of sorting algorithm where it has the same basic functionality as the bubble sort. We're given a unsorted list, it will return a sorted list, but can be much more effective and time saving. The idea behind the insertion sort is it takes an unsorted list and splits it up into two smaller lists, a smaller sorted list and an unsorted list. And you can compare the numbers in the unsorted list with the numbers in the sorted list. And if you find where the unsorted number belongs right away, you can cut out all the other comparisons with the smaller or larger numbers in the sorted list. So let's take a look at how this works. The first time running through, it'll do the same as the bubble sort will. It'll check the first two numbers in the list and compare them, and since 2 is smaller than 3, it switches those. And now we are left with a sorted list of 2, 3 and an unsorted list of 4, 1, 5. So the next step, we compare 4 with the first number of the sorted list, which is 2, and then the next number, which is 3. Well, it's greater than 2, so it goes to 3, and it's greater than 3, so it belongs after 3. Now we are left with 2, 3, 4 in the sorted list and 1, 5 in the unsorted list. So another round of comparisons, compare 1 with 2, and since 1 is smaller than 2, it goes in front of 2, and you don't have to compare 1 with 3 or 4. We just know it is smaller than 2. And lastly, we compare 5 with 1, and it's greater than that, so go to 2, 3, and then 4, and it's greater than 4, so it belongs at the end of the list. And we are left with a sorted list, 1, 2, 3, 4, 5. So as you can see, the insertion sort can be much more effective, especially as n grows larger. Thank you for taking the time to watch the presentation.